So here we go with the solutions for the dynamics test. What I want you to do is look through all these solutions, watch the video to see all the solutions, and then compare them with your own answers and start making notes on where did you go wrong with a given question, if indeed you did. And if you didn't, well done. So we'll start with the first of the long answer questions, which is number 8. I'll do the 7 multiple choice ones later on. And we're asked to calculate the acceleration of the yacht, not the yacht, the boat. Acceleration formula, A equals V minus U over T. Sub in the numbers we're given in the question and answer 0.192 meters per second squared. And this is a good example of what's known as a standard 3 marker, because it's 1 mark for selecting the correct formula to use, 1 mark for substituting the values incorrectly, and 1 mark for getting the final answer correct, which does include the units. Next question was number 9. Describe the motion of the rowers, and it's a constant speed or a uniform velocity. You could, if you wanted to, call it a uniform speed or a constant velocity. Any combination is acceptable, well, apart from a constant uniform or a speed velocity, I suppose. So constant speed, constant velocity, uniform velocity, uniform speed. And for number 10, you're asked how far did the rowers travel in the 510 seconds? Well, first segment of the speed time graph is a triangle, so a half times 4.8 times 25, because the first segment was 4.8 meters per second at their highest speed, and that was a 25-second segment. That gives you 60 meters. Then the big stretch in the middle at a constant speed, 4.8 times 425 seconds. That segment ended at 450 seconds, but it began at 25 seconds, so it's 425, not 450. That gives you 2040 meters. And then for the deceleration at the end, a half, because it's a deceleration, times 4.8 times 60. We know it's a deceleration because it's a triangle and the slope's going down from left to right. That gives you 144 meters. Add them all up and you get 2,244 meters. And for part 11, what's the average speed of the rowers? The total distance, which you got in part 10, 2,244, divided by the total time, which is 510 seconds, and that gives you an average speed of 4.4 meters per second. Now for the weightlifter question, the upwards force is equal and opposite. Those are the key words, equal and opposite to the weight force. So the weight force is down the way, and in order to hold everything stationary, the weightlifter has to apply an upwards force that is equal in magnitude and opposite in direction to the downwards force, which is of course the weight of the barbells that he's lifting. Question 13, we use our weight equals mass times gravity formula. 1,176 newtons is the force, that is the weight. The mass is what we're trying to find out. Gravity is 9.8 on Earth. There's nothing in this question about it not being on Earth, so we just assume it's on Earth and use 9.8. So the mass is 1,176 over 9.8, which gives us a mass of 120 kilograms. We're then asked to calculate the acceleration of the weights as the weightlifter pushes them upwards. The weightlifter pushes them upwards with a force of 1,344 newtons. But we must remember that it is the unbalanced force that causes accelerations. So the unbalanced force is the 1,344 newtons the weightlifter is pushing up with, minus the 1,176 newtons that is the weight downwards. So the upwards force from the weightlifter minus the downwards force from the weight of the weights gives us an unbalanced force of 168 newtons, which we then divide by the mass of 120 kilograms to get the upwards acceleration of 1.4 meters per second squared. And strictly speaking, although it's unlikely to be penalised at National 5, we should have some sort of indication, either an arrow, they don't really like that anymore, the word upwards would be better, to show the direction of the acceleration, because remember, acceleration is a vector, not a scalar. Lastly, the trolley going down ramp questions. In 15, what other item did the experimenter need to measure? They needed to measure the time for the card to pass through the light gate X. Now it's important that is the card on the trolley, not the trolley, because there's no guarantee the length of the card that's passing through the light beam on the light gate is the same length as the trolley. It might be, but it might not. So it's important that you specify it is the card passing through the light gate at X. Then asked to calculate the speed at Y, and we do that with the length of the card divided by the time for the card to pass through the light gate at Y. And according to the wording in the question, that's 0.045 meters for the length of the card divided by 0.098 seconds for the time for that card to pass through the light gate at Y, which gives us 0.46 meters per second as we were asked to find out. Lastly, we're asked to find the acceleration of the trolley down the ramp. So our acceleration formula, the final speed at Y minus the initial speed at X, and then whatever that equals divided by the time it takes to get from X to Y. So 0.46 minus 0.32 leaves you with 0.14. 0.14 divided by 0.56 gives you 0.25 meters per second squared.
Now for the multiple choice questions. Number 1, the answer is B, because X is not a constant velocity, Y is a constant acceleration, and Z is not a constant acceleration. So X is false, Y is true, Z is false, so the answer must be B. Number 2, the answer is D. This is because there is a constant speed on the horizontal portion of the track, and then the ball will accelerate down the slope. So we're looking for a horizontal to show the constant speed, and then an upwards line to show the acceleration. So that leaves us with D being the correct answer. E for number 3. Number 3 is E. That's because the slope is the same. Nobody in that question did anything to alter the slope of the ramp. That means the acceleration is going to be the same. But by starting at a point further down the ramp, the car has less time to accelerate, and therefore it reaches a lower average velocity. So E is our answer there. Number 4 is also E. The section of the graph ST has the steepest upwards line. So steepest gives us the largest value of either acceleration or deceleration, and upwards line gives us it's an acceleration. So if it's sloping downwards, then it's a deceleration. So ST, because it's the steepest upward line, steepest gives us the greatest acceleration, upwards confirms that it is an acceleration and not a deceleration. Number 5 is a nice neat calculation, and the answer is B, because when we use our correct formula, V equals U plus AT, the initial velocity of 6 plus the acceleration of 2 for a period of 4 seconds, 2 times 4 is 8, plus 6 is 14 meters per second. Number 6, well, is another what's true and what's false, and the answer is B is the answer we need. If the weight was less than the air resistance, then the package should be decelerating, and it's not, it's at its terminal velocity, so that's the first statement is false. The forces acting in the package are balanced at terminal velocity. Yes, they are. Yes, they definitely are. So that one is true. And then the last statement, if the package is accelerating, then it hasn't reached its terminal velocity yet. So the package can't be accelerating because we've already been told that it is at its terminal velocity. So once again, the first statement is false, because if the weight is less than the air resistance, the package should be decelerating, and it's not decelerating, it's at its terminal velocity. The second statement is true because we're told in that second statement the forces are equal and opposite, they're balanced, and that is exactly what happens at terminal velocity. And 6 answer should be B. The last statement is not true because if the package was accelerating, it hasn't reached its terminal velocity yet, so that's false. And last, by all means least, Number 7, the answer we want is E. And that is because of Newton's third law, which says that for every action force, there is an equal and opposite reaction force. We're told in the question that the rocket engine exerts a force on the exhaust gases. So there's your action force. The rocket engine exerts force on the exhaust gases. So your reaction force must be the exhaust gases exerting a force on the rocket engine. And that means we're picking E for number 7.